Greetings, guys. So with me now, I've got a cycle geometry question. If we can see, they're saying BAD is a cyclic, BAED is a cyclic quadrilateral. So BAED is a cyclic quad, and then BA is parallel to DE. BA is parallel to DE. We can see by these arrows, and then they are saying DE is equal to BE, DE is equal to BE. So the two lines are equal. Let's make them in green. Two lines in green. So these two lines are equal. If these two lines are equal, we know that the base angles will also be equal. So angle B2 will be equal to angle D2 because they say these two sides are equal. So the base angles will be equal. Okay, and then they're saying angle AED is equals to 70 degrees. So this entire angle is 70 degrees, right? Okay, and then we can see that this line is a tangent to the circle at D. This line is a tangent to the circle at this point of contact. The point of contact is D. So we can clearly see that the line goes all the way, right? It's a tangent to the circle at D. It touches the circle once, only at D, right? You will excuse my drawings. Okay, so if we go on to the question, so guys, quick revision. If we talk about a cyclic quadrilateral, about a cyclic quadrilateral, we simply mean that its edges are along the circumference of a circle, right? That's what we mean. And then with the cyclic quad, we know that let's say we have angle A, B, C, and D. With the cyclic quad, we know that angle A plus angle D are supplementary. They add up to 180 degrees, right? This angle and this angle add up to 180 degrees. The same way with angle C and angle B. They are also supplementary. So opposite angles of a cyclic quadrilateral are supplementary, right? Okay, let's get down to the question. Let's get on with it. So the first question, they're saying we should calculate the size of angle A, which is 2 marks. The size of angle A, which is 2 marks. Okay, angle A is this one, angle A is this one. Okay, they told us that this angle is 70 degrees and this line is parallel to this line. This is a transverse. So this is D. Let's say this is D, this is E, and then here we have B, here we have A, and then we have this line BE, right? This is the line BE. Okay, and then what's happening? Yeah, in a way we have these two angles, right? You know that if this line and this line are parallel, then these two angles are supplementary, right? If this is A, this is B, angle A plus angle B add up to 180 degrees. What is the reason? The reason is that they are co-interior angles, right? You know that co-interior angles are supplementary. So if you can check here, this is the line, this line is parallel to this line. So we can see that these two angles, this angle, this angle, and this angle are co-interior, right? So we will say angle E, okay, yes, angle A plus angle E is equals to 180 degrees. They said we should give reasons as well. The reason is that they are core interior angles, right? The co-interior angles are supplementary. So angle A is equals to 180 degrees less angle E. This is 180 degrees less angle E. They told us that it's 70 degrees. The entire angle is 70 degrees. So this says angle A is 110 degrees. This angle here is 110 degrees. The reason being it is co-interior with angle E. So this will be 110 degrees, right? 110 degrees. Okay, next question. So we got angle A, which is 110 degrees. The reason is that it is co-interior with angle E, and then co-interior angles are supplementary. They add up to 180 degrees. Okay, moving right along. Angle B1, angle B1, angle B1 is this, right? Angle B1 is this, angle B1 is this. Okay. We just talked about the opposite angles of a cyclic quad. Opposite angles. So B2 plus B3, this angle, this angle, this angle, this angle, if we add it with this angle, they must give us 180 degrees, right? Right? Okay, so angle B. Okay, so this one, let us put it in this way. Eh? It is one angle though, eh? Angle B2 plus B3 is one angle, right? Plus angle E as a whole, angle E as a whole. I'm scared to say angle B here, because we also have this one which is outside the cyclic quad. Hence, I'm doing this. But also in here, we can still say E1 plus E2, right? Which will simply mean angle E, this one, right? Okay, so these two will give us 180 degrees. What is the reason? The reason will be, should be writing it here, but then maybe like I say, when the reason is opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are supplementary, right? So angle B2 plus B3, B2 plus B3, angle B2 plus B3 is equals to 180 degrees less angle E. Let's just call this one angle E, right? Since we do not have any other angle, let's just call it angle E. So this will be 180 degrees less angle E. It was given, they said it's 70 degrees. Then it says this angle B inside the cyclic quad is 110 degrees. Why? Because the opposite angles of a cyclic quad are supplementary. But we are not looking for this angle. We are looking for this angle B1, right? If we say angle B1 plus angle B2 plus angle B3, we expect them to give us 180 degrees, right? The reason being that they are angles on a straight line. Angles on a straight line, right? They are angles on a straight line. So B1 is equals to 180 degrees minus angle B2. This is, let's put it as one angle B2 plus B3. B2 plus B3 is is 110. So this will be 70 degrees Celsius, right? B1 will be 70 degrees Celsius. We're good, ne? So this one here outside it's 70 degrees Celsius. We're good. We're done with this one. Moving right along. D2. D2. Where is angle D2? Oh, here is angle D2. Here is angle D2. Oh, okay. So yeah, we said well, you already know about opposite angles of a cyclic quad, right? So if we say angle D2 plus angle A, what do we expect to get? We expect to get 180 degrees. Why? The reason being opposite angles of a cyclic quad. The opposite angles of a cyclic quadrilateral are supplementary. They add up to 180 degrees, right? So angle A is equals to 180 degrees less angle D2. This is 180 degrees less, no, sorry, excuse me, angle D2. We are looking for D2. So it will be, D2 will be 180 degrees less A, right? And then we got A as 110 degrees. Therefore, D2 will be 70 degrees. Angle D2 will be 70 degrees. The reason is that they are opposite angles of a cyclic quadrilateral, right? Angle D2 and angle A. So we're good. We're good. So we said D2. We just got D2 now. We got D2. We said D2 is 70. D2 is 70. And because these two sides are equal, so the base angles will also be equal, meaning this is also 70, right? Meaning this is also 70, right? Okay, nice one. Moving right along, B2, angle B2. Where is B? Oh, sorry. I jumped the gun. So angle B2. Okay, let's give the reason. So D2, D2, angle D2 is equal to angle B2. The reason being angle B2 is equal to angle D2. The reason being their base angles to equal side, right? Base angles of equal sides. We know that base angles of equal sides are also equal, right? Therefore, angle B2 is equals to 70 degrees. Why? Because we had already discovered that D2 is 70 degrees, right? All right. The last one, angle D1. Angle D1, what is, oh, here is angle D1. Here is angle D1. Here is our angle. Here is our angle we're looking for. Okay, now there is a theorem. It is called the tan-cot theorem. They told us that this line CD is a tangent. This line is a tangent, meaning it touches the circle only once, right? It touches the circle only once. So there is a theorem. It is called the tangent and the cot theorem. In short, we call it the tan-cot theorem. So the theorem simply means, let's say maybe we had a triangle like this, a triangle like this, right? And then say maybe here we have a tangent. This is the point of contact, right? This is the point of contact, right? Here we have angle A, here we have angle B, here we have angle C. Let's say here we have angle D, right? So angle D, if you can see, is the angle between a tangent. Here is the tangent and a chord. Here is a chord, right? You remember a chord is a line that divides the circle into two, right? A chord is a line that divides the circle into two. So here is our chord, and then here is our tangent. So if we at the end of the chord, and then slide, then we will get the angle. So the tan-cot theorem, the tan-cot theorem says the angle between a tangent and a chord is equal to the angle in the alternate segment. So the angle between a tangent and a chord, which is this angle, is between this tangent and this chord. It is equal to the angle in the alternate segment. So in this case, it says angle D is equals to angle B, according to the tan-cot theorem, right? Here is the tangent, here is the chord. We put our fingers on either end of the chord, and then we slide the other two sides, right? Then that angle is the angle that is equal to the angle between the tangent and the chord, right? So in this case, we can see that a D1 is the angle between the tangent. The tangent here is, the tangent here is the tangent, and then here is the chord. DB is the chord, right? So the angle should be equal to the angle in the alternate segment, right? So we look at the triangle. We look at the triangle. So it means in this case, angle D1 is equals to angle E1, right? It says angle D1 is equal to angle E1, right? Because if we slide, here is the chord again. We slide, we end up to angle E1, right? So a tan-cot theorem, a tangent, and then the shape you're interested to go inside the circle is a triangle, right? So we can see that according to the tan-cot theorem, D1 is equal to E1, right? So what is E1? What is E1 is the question. What is E1? E1 we don't know, but we know that D2, D2 plus E1 will give us 180 degrees. What is the reason? Angles of a triangle, right? Angles of a triangle add up to 180 degrees. So angle E1 is equals to 180 degrees less angle D2 less angle B2, right? So 180 degrees, we have 180 degrees less. This is 70 degrees, and this is 70 degrees. So this will give us 40 degrees, right? So E1 is equal to 40 degrees. If E1 is 40 degrees, therefore D2 is also, D1, right? D1 is also equal to 40 degrees, right? So yeah, this was it, guys. Circle geometry. Yeah, more is coming. Otherwise, more is coming. Thank you. Meet you on the next one.